Number 15 asks us to evaluate some limits. So evaluating limits, and it's good to have an idea of what's going on here, but I do want you to be able to show using the stuff we've done in class. So A asks limit as x goes to infinity of x squared plus 3x plus 2 over 3x cubed plus 9. And what was my idea? I always want to factor out the biggest power of x in the denominator. So I get x cubed times 3 plus 9 over x cubed, all divided by x cubed. And if I weight this, I get 1 over x plus 3 over x squared plus 2 over x cubed. And I can FOIL that to make sure that actually works, but that's the idea. So these x cubes cancel, and I'm left with limit x goes to infinity of 1 over x plus 2 over x, 3 over x squared plus 2 over x cubed over 3 plus 4 over x cubed, 9 over x cubed. And now I take my limit. So the 1 over x, anything with an x under it goes to 0 because x is going to infinity. And I'm left with 0 over 3 or 0. And this makes sense with our intuition, right? Because the bottom is bigger than the top, so the denominator should dominate the numerator. So now for part B, limit x goes to infinity of x cubed plus 2x plus 7 over 2x squared plus 7. And again, our idea is the top is bigger than the bottom, so the top should dominate. The numerator is bigger than the numerator should dominate. And therefore, this limit should be, we have a minus infinity though, so let's be careful. So it's going to minus infinity, but the numerator should dominate. That's the idea. So same thing, take the biggest power of x I can out of the denominator, x squared divided by x squared, x plus 2 over x plus 7 over x squared. Delete those. And I need my limit. Limit x goes to minus infinity. So this is limit x goes to minus infinity of x plus 2 over x plus 7 over x squared divided by 2 plus 7 over x squared. What happens is I take my limit. Anything with an x on it goes to 0. And I'm left with limit as x goes to minus infinity of x over 2. So here I'm making x really big and negative. So that's negative divided by 2 isn't going to change anything. So I get that this limit is minus infinity. And that's my final answer. And again, it's important, limit here is going to minus infinity, not plus. Okay. So part C, did I label which number this was? Yes. Part C, we have limit as x goes to infinity of 10x squared plus 2x plus 4 over 4x squared plus 10. And what do I want to do here? Same thing I did on the last two problems. I want to take out the x squareds. And I get 10 plus 2 over x plus 4 over x squared. Here I'm going to start going a little bit faster. 4 plus 10 over x squared. So the x squareds both cancel. And then when I take my limit, These things are going to cancel. And I'm going to be left with this is equal to 10 over 4 or 5 halves. Right, and this makes sense with our intuition because the powers on top and bottom are equal. Finally, D. This one's a little tricky. Limit as x goes to infinity of the square root of a big scary polynomial, 16x to the fourth plus 2x squared plus 3x over 3x squared. Again, I want to take out an x squared here. So get rid of an x squared on the top and bottom. But I need to be a little bit clever. So I want to take an x squared, but it's under a square root. So the thing that I keep in mind is x squared is equal to the square root of x to the fourth. So put that under there. I can take out a square root x to the fourth, same idea. 16 plus 2 over x squared plus 3 over x cubed. And then what was the denominator? 3x squared. Okay. That looked confusing. And now what happens? I can say this is limit as x goes to infinity of square root x to the fourth because of the way square roots multiply. I can say square root of one thing times another thing is the square root of the first times the square root of the second. So that's what I'm doing here. X cubed over x squared times 3. These cancel because they're both x squared. One's just x squared in disguise. And important, I'm taking the limit as x goes to infinity. So I'm going to use positive x squared. And I'm left with limit as x goes to infinity, square root 16 plus 2 over x squared plus 3 over x cubed over 3. And now anything with those cancels. And I'm left with limit as x goes to infinity of square root 16 divided by 3, which is also known as 4/3. And that's my final answer.